All right, we get to one of my favorite parts of why, well, I don't know of all why we do math, why we do a lot of algebra, but there's so much beauty in this that I hope you appreciate it. And I also hope at one time, sometime in your life, you're gonna be able to do this exact same thing without any help from anyone else. If you do that, I'll buy you lunch or something. So what we have here, do you recognize that? We have a standard quadratic expression. And wouldn't it be nice that we can take this standard expression with variables and maybe we can solve this for x to maybe get a pattern that we can use over and over and over again. So rather than solving each quadratic expression, maybe we can solve it once and for all for every quadratic expression. So I have some ax squared plus bx plus c equals 0 for values of a greater than 0. Well, how do we solve this for x? Well, we're just going to do the same process. We want to ensure that our x squared term has a coefficient of 1. So we're going to divide everything through by a. So I have an x squared plus a b over an a plus c over an a equals 0 over a. To solve this by completing the square, we want to have the x terms on one side, non-x terms on the other side. This opens up the opportunity to find out what that little corner piece is. So there's going to be some magic value right here that makes this a perfect square. How do we find that? We take the middle term, I'll do it over here, divide by a 2, and then square that. So middle term divide by 2, this becomes a b over a 2a. Square that, becomes a b squared over a 4a squared. So I'm going to add that to my left side. In order to do that, I need to add it to the other side as well. I hope you see that we haven't done anything really odd yet, other than we're using variables rather than specific numbers. This value, this b squared over 4a squared, that was a perfect number that allows this to turn into a perfect square, which is going to be an x plus a b over 2a. On my right side, I'm just going to take one step to clean it on up because I need to add those together a little bit. So this is going to be a b squared over a 4a squared. To get common denominators, I need to multiply that side by a clever version of 1, which is going to be a 4a over a 4a. That's an a, not an ugly 9 or a squiggly or whatever it might be. So that becomes a case. This becomes a 4ac all over a 4a squared. So now I can add the right sides. Using the square root property, take the square root of both sides. X equals x plus ba equals plus or minus the square root of all of this. I'm going to go ahead and combine those underneath 1, so that's b squared minus 4ac all over 4a squared. All right, take a breath, shake it out. All right, let's continue. To get x by itself, let's subtract b over 2a to both sides. So I have x equals minus b over 2a plus or minus all of this stuff. I got about 2 more steps and I think I'm done. The right side, I can reduce that down. I have a radical or a square in the denominator in that radical. So let's see if I can do it just keeping it down here. So the top will just be a square root of b squared minus 4ac. The denominator, the square root of 4ac or 4a squared, which is just a 2a. And then from there, I do have 2 terms that have common denominators. So let's just combine those up. So I get x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. You guys hear that? Where's that noise coming from? I think that's people cheering. There's applause going on. I don't know where it's at, but I know you hear it too. That what we are able to do, me and you, based on the skills that we've learned all through our entire algebra sequence, adding fractions, dealing with fractions beside radicals, squaring numbers, all those types of things, we're able to derive where we got a single solution for x. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. And what we call this is we call this the quadratic formula. And this tells me that for any quadratic that I have, whose value of a is greater than 0, its solutions of x can be simply found by putting the coefficients in for the specific spots and solving that. So again, I really think this is a thing of beauty. I really hope at some point in time you can drive this on your own because you have the skills to do that. And then once you do that on your own, then you have my permission to use this formula as a shortcut to solve any quadratic that you want. Deal?